Hello student, welcome to maths class and today we'll do perimeter and area. Our learning objective in this chapters are perimeter, area and area of triangles. So all these things we are going to cover in this chapter. Start with the introduction. A simple closed curve divide the plane into three parts or region. In the figure 1 you can see the first part. The part of the plane that containing all the points enclosed by the closed curve, that is called the interior part of the region. This is the interior part of the region. Clear? The curve itself and the part of the plane that containing all the point outside the curve, that is called the exterior. So this is the exterior region. Clear? So we are generally interested in the boundary of the geometrical figure. Yes, and their enclosed region. The boundary of any geometrical figure, that is called perimeter. And the enclosed region that inside it, that is known as the area. Now we'll take perimeter. The perimeter of the closed shape is total length around its boundary. The total length around the boundary of any shape, that is known as its perimeter. If the shape consists entirely line segment, the perimeter is found by adding the length of all sides. So, if the shape is containing line segment only, then perimeter will be what? The perimeter will be the length of all sides, the sum of length of all sides. Clear? In simple terms, the perimeter represents the distance covered along the edge of the closed shape if we travel around once. For polygon, the perimeter is the combined length of all sides. Perimeter measured are expressed in the unit of length such as the meter, centimeter and so on. So, the unit of perimeter is same as the unit of the length. Now, perimeter of rectangle. Let ABCD a rectangle. Then the perimeter of rectangle, that means sum of length of all sides, that is AB plus BD plus CD plus AC. Clear? Now, we know in rectangle opposite sides are equal, so we can write AB plus BC plus BC, that is equals to 2AB plus BC, means 2 length plus breadth. Thus, the perimeter of the rectangle is equals to 2 into length plus breadth. Note, length of the rectangle, that is equals to 1 upon 2 perimeter minus breadth, and breadth of the rectangle, that is equals to 1 upon 2 perimeter minus length. While calculating the perimeter of the rectangle, its length and breadth must be expressed in the same unit. That we have to keep in mind whenever we are calculating perimeter or anything. The unit should be same for all the measurement. Next is perimeter of square. Since the square has 4 sides, so perimeter, that is equals to sum of all 4 sides, and we know in square all sides are equal. Here we have taken side as a unit. So perimeter equals to 4 into length of a side, 4a. So that is the perimeter of the square. Clearly the perimeter of the square is quadruple of the length of its side, means 4 times length of its sides. Next is perimeter of triangle. A triangle has 3 sides. So let A be a triangle. Therefore, perimeter of the triangle will be the sum of 3 sides, means AB plus BC plus CA, A plus B plus C. So, perimeter, that is equals to sum of length of all sides. If we talk about the equilateral triangle, in equilateral triangle, all 3 sides are equal. So, perimeter, that is equals to AB plus BC plus AC. All 3 sides are equal, so we can write AB plus AB means 3 times of the length of one side. So, perimeter of equilateral triangle, that is equal to 3 into length of sides. Clear? Now, we will take some example here. Example 1. Find the perimeter of a rectangle whose length and breadths are 15 centimeter and 7 centimeter respectively. So, length and breadths are given. We know the perimeter of the rectangle, that is equals to 2 into L plus B. So, here length and breadth are given, we can use the formula and find out. So, perimeter of the rectangle ABCD, AB plus BC plus CD plus DA means length of all sides, or we can use the formula and directly find out the perimeter, that is equals to 44 centimeter. Rectangle ABCD 2 AB plus 2BC, length plus breadth. So by using this formula, the perimeter is 44 centimeter. Clear? Next, example 2. Find the perimeter of the following figures. So we have to find the perimeter. Perimeter equals to sum of length of all sides. So in the figure 1, perimeter of the triangle ABC, that is equals to AB plus BC plus CA, means 3 centimeter plus 6 centimeter plus 5 centimeter, total 14 centimeter. In second figure, perimeter of isosceles triangle means two sides are equal, so 5 plus 5 plus 8, 18 centimeter. Perimeter of the rectangle PQRS, 2 into length plus breadth, means 2 into 4 plus 3, 4 plus 3, 7 into 2, 14 centimeter. Now we will take another example, example 3. The length and breadth of the rectangle are 12 centimeter, 8 centimeter respectively. Find the perimeter. So length and breadth are given, we have to find the perimeter. The unit are same, both are given in centimeter. So we will use the formula 2 into L plus B. So 2 into 12 plus 8, that is 40 centimeter. Another example, Pawan walked twice around the rectangular field with the length of 30 centimeter, breadth 25 centimeter. Neha walked thrice around the square field whose side are 40 centimeter. What distance is covered by each one? Who covered more distance by how much? So first we will find the perimeter. The distance covered by Pawan in one round, that is equals to the perimeter of given figure, 2 into L plus B. Clear? That is 110 meter. Now Pawan walked twice, 2 times. So we will multiply it by 2. So total distance covered by Pawan is 220 meter. Now distance covered by Neha in one round, that is 4 into side, that is 4 into 40, 160 meter. Now she has gone thrice around the field, so 3 into 160, 480 meter. Now the difference, 480 minus 220, that is 260. So Neha has covered the more distance, how much more? 260 meter. Next example, example 5. Find the cost of fencing the square park of the side 250 meter at the rate of rupees 50 per meter. So first we will find the, we have to fence, so we have to find the perimeter. Perimeter of park, 4 into side means 4 into 50, 1000 meter. Now cost of fencing 1 meter, that is equals to rupees 50. So cost of fencing 1000 meter, 1000 into 50, that is 50,000 rupees. Clear? Now example 6. How many rectangles can be drawn with the 16 centimeter as the perimeter? Give that side are positive integer in centimeter. So we know that the perimeter of rectangle, that is equals to 2 into length plus breadth. Here the perimeter 16 centimeter, 16 equals to 2 into L plus B. So L plus B, that is equals to 8 centimeter. So total length and breadth should be equal to 8 centimeters. So we can consider the measurement of the length and breadth such that their sum is always 8 centimeter. Clear? So keeping that in mind, length is always greater than or equal to breadth. So we'll make such combination. Like we can take combination and like length is 7 and breadth is 1. Then L plus B is 1. 6 and 2, 5 and 3, 4 and 4. So these combination we can take. Thus we obtain 4 rectangle, those perimeter is 16 centimeter and sides are positive integer. Clear? Note. Observe that the last case we consider both length and breadth 4 because every square is a rectangle. That's why we have taken length and breadth both equal. Next we will take example 7. Find the perimeter of each of the following figure. So we know perimeter is the sum of length of all sides. So in the given figure, that is equals to 4 plus 2 plus 1 plus 5. So that is equals to 12 centimeter. In this figure, the perimeter sum of length of all sides 4 plus 1 plus 5 plus 2 plus 3 plus 4 plus 1 plus 3 plus 2 plus 3 plus 4 plus 1 plus 3 plus 2 plus 3 plus 1 plus 1, 3 plus 2 plus 3. So that is equals to 52 centimeter. Clear? Simply we have to find the sum of all sides. Now example 8. Find the fence of costing rectangular park of length 175 meter and breadth 125 meter at the rate of 12 rupees per meter. So first we'll find the perimeter. Length and breadths are given. Perimeter equals to 600 meter. Now we have to find the cost of fencing. So we'll fence around the boundary of any given figure. So cost is given here rupees 12 per meter. For 1 meter it's rupees 12. So for 600 meters, 600 into 12, 7,200 rupees. Next is example 9. A rectangle having the side of length 5 cm and 3 cm made using the piece of the wire. If the wire is straightened, then bent to form a square, what will be the length of the side of square? So first we'll find out the perimeter of rectangle. That is equals to 2 into 5 plus 3, that is 16 centimeter. Now we have straightened the wire and make a square. So the perimeter will be the same, that is 16 centimeter. 4a equals to 16 centimeter. So a equals to 16 by 4 centimeter. So which is the required length? So sides would be 4 centimeter. That is the required length of the side of square. Clear? Next example, example 10. Find the length of the third side of the triangle having the perimeter 55 centimeter, having two sides 20 and 14 centimeter respectively. So perimeter, sum of all three sides. So perimeter is 55. Suppose the third side is x. So x plus 14 centimeter plus 20 centimeters. So x equals to 55 minus 34, 21 centimeter. Now we'll take example 11. A piece of the string is 36 centimeter long. What will be the length of each side if it is used to form a square? So piece of string that is 36 centimeter long and we are making square out of it. So the perimeter of the square that is 36, because we are making the square using the same string. So sides would be 36 upon 4, 9 centimeter. Now a triangle with all three sides are equal in length. So again the perimeter is same. So we'll divide it by 3. So each side will be 12 centimeter. Now in hexagon have 6 sides. So we'll divide by 6. So each side will be 6 centimeter. Now example 12. A farmer has a rectangular field having the length of 230 meter and breadth 160 meter. He wants to fence it with the 3 rounds of rope as shown. What is the total length of rope needed? So first we'll find the perimeter of rectangle, that is 2 into L plus B. L is given here as 230 meter and breadth is 160 meter. So total perimeter 470 meter. Now that is the distance covered in 1 round. So total 3 rounds. So we'll multiply it by 3. 2340 meter. Clear? Next is learning point 6.1. So practice all the questions given in this exercise. You have to practice all the questions given here. Next is area. Look at the adjoining figure. The shaded portion of each plane figure is called the area. So the area is the measurement of the region bounded by the plane. So the region bounded by the plane, that is called the area, whether it's for rectangle, square, triangle or any other figure. So we have already know about the perimeter of the plane figure. It is nothing but the length of the boundary of the region. In the previous exercise, we have seen that the many rectangle can be formed in the different length and breadth combination having the same perimeter that we have done in the examples. Look at the following region in figure 15. So you can see there are different figures given here. The length here is 2 centimeter, length is 3 centimeter and breadth is 2 centimeter. Here the length is 4 centimeter and breadth is 1 centimeter. So figure A, what will be the perimeter? The perimeter will be 2 plus 3 plus 2 plus 3. 10 centimeter. And the figure B, this one, the perimeter that is equals to 4 plus 1 plus 4 plus 1, again 10 centimeter. Although they are different figures, but their perimeter is same. Thus we see that the both have the same perimeter, 10 centimeter, but the enclosed region are not same. In the figure 15a, there are 6 squares are inside. So you can see there are total 1, 2, 3, 4, 5, 6 square, and in this 1, 2, 3, 4 square. Clear? But the enclosed region is not same. In figure 15a, the area is 6 square side, 1 centimeter cover the region where we require 4 square with the side 1 centimeter fill the region in figure 15b. So clearly figure 15a has a larger than figure 15b, and we come to the conclusion there is a region having the same perimeter but not the same enclosed region, means not the same area. We will have to find some method other than the perimeter which are able to compare the magnitude of two given region. So now we are going to introduce the concept of area and the region, which we give us the idea of the magnitude of region. The concept of the area gives us practical advantage in real life situation. Standard unit of area. The fixed distance or the length of the example 1 centimeter or 1 meter are not taken by us. Abbreviately, these are the actually standard unit for the measuring length and distance, in the sense that everyone understand in the world how much 1 centimeter and 1 meter, because they are the standard units and they are using worldwide. We measure all the distance of length in the term of standard unit. In the same method we shall adopt for measuring areas. All areas will be expressed in the term of the standard unit of area. To measure the area of a small enclosed region, we use the square with the side 1 centimeter as the standard unit, which cover an area of 1 square centimeter or 1 square centimeter. So since the figure 17a, the region is completely covered by 4 such square, so we will say the area is 4 square centimeter. Similarly, in 15b, they are completely covered by 5 square, so we will say the area is 5 square centimeter. Here you can see. In general, if a simple closed region is m square, side 1 centimeter, then we say required area is m centimeter square. Clear? So two other popular standard unit of the area is 1 square meter, or we will write 1 meter square. 1 square millimeter will write 1 mm square. Clear? See the above figure and realize that the 1 meter square indicate it is closed by the square region with the side 1 meter. Similarly, 1 millimeter indicate it is a small closed square region with side 1 millimeter. Since there are various units of measurement of length and distance like meter, decimeter, decameter, kilometer, millimeter, so these are different units. We will always express the area in square unit. Clear? So there are many standard units for area. For measuring larger areas such as the playground or plot of land, we will use unit like meter square. For measuring areas of the countries, we use even bigger unit like kilometer. Kilometer square. The table given on the next page will see you idea of different unit of length corresponding to area and their relationship. So you can see 1 centimeter, that is equals to 10 millimeter, 1 centimeter equals to 10 centimeter, 1 meter equals to 10 decimeter, 1 decameter equals to 10 meter, 1 hectometer equals to 10 decameter, 1 kilometer equals to 10 hectometer, 1 kilometer equals to 1000 meter. Clear? So these are the unit. How can you convert from one to another? 1 centimeter square to convert into millimeter square. So 1 centimeter is to 10 millimeter. Here we are using square unit. So 10 into 10, that is 100 millimeter square. Like this we can convert. Clear? Next, finding area by counting squares on square paper. Areas of the irregular shape can be found out by using the squared paper as a tool for measuring areas. However, for irregular shape, we will be able to find the exact measurement, but we will get an appropriate result. Figure 20 shows the part of the square paper. It is divided into squares of side 1 centimeter by the thick lines. Here you can see by the thick lines it is divided into square of 1 centimeter. Clear? One such square is shown as the top of the corner of the left, which is further divided into 10 equal subparts, side of 1 millimeter each. The following rules are to be followed to determine the area of closed plane figure. drawing on the square paper. Rule number 1. So first we'll count the number of complete square enclosed by the figure shown by the region. In figure 20, the number of the complete square are 5. So first we'll count the number of complete square. Now we'll count the number of square that is more than half. The number of square that are more than half whose portion is enclosed by the figure is shown by this. In the figure 20, the number of such square are 7. So the number of square who enclosed more than half area, that is 7. Now we'll count the number of exact half square, lengthwise, breadthwise or diagonally in the figure 20. There is no such half square, so number of half square is 0. Now next, compute the area. How will you compute the area? Number of complete square plus number of square more than half area enclosed by plain figure drawn on the square paper plus 1/2 number of exact half square. So area of enclosed region here 5 plus 7 plus 12 into 0. So that is equals to 12 square unit. So here the area closed 5 plus 7 plus 1/2 into 0, that is equals to 12 square centimeter. Mind that this is not the exact area but quite close to the same. Now area of rectangle by using formula. So that was the way to find in the area of irregular figure like given here. Now we'll use the formula. We have seen using square paper we can measure the area of closed region. Although it is not the exact value, we would like to introduce the method which give the exact area of region even if we have to restrict our choice to very special type of region. Let us do an activity. So first we'll draw a rectangle ABCD on the square paper, taking the length to be 4 cm and breadth 3 cm. So we should arrange the drawing in such a way that the side of the rectangle fall along the thick line on your square paper. What do you find the area be? How many square does it contain? It contains 4 into 3, total 12 square. So the simple method to observe the area of the rectangle ABCD is 12 square centimeter. 4 into 3. Clear? Here we notice that the number of rows here are 3 enclosed with the equal breadth of the rectangle, that the number of square in each row is nothing but the length. So the area of rectangle 4 into 3, 12 square centimeter. 1, 2, 3, 4, 1, 2, 3. So 4 into 3, 12 square centimeter. Thus the area of rectangle length into breadth, L into B. From the formula we can see length equals to area upon breadth and breadth equals to area upon breadth. Clear? Note, unless stated otherwise, the measure of the longer side of the rectangle considered as length and that of the smaller side, that is breadth. It is necessary to write length and breadth in the small unit. Next is area of square by using formula. We know that the square is also a rectangle with the length that is equals to breadth. So area of square that is equals to length into breadth equals to side into side. So area of square that is equals to side square. Now we'll take some example here. Find the area of the following figure drawn on the square paper. So we have to find the area. In first figure, what will be the area? Rectangle ABCD contain 8 complete. So we can see in the figure 22A. Complete square that is 4, complete square that is 8 and 4 are half. So 1/2 into 4. So 8 plus 2, 10 centimeter square. In figure B, in the triangle PQR contain 1 complete square and 3 more than half square. So more than half will take as full and 3 less than half. So according to the area will be 1 plus 3 because more than half will take as 1. So 1 plus 3 that is equals to 4 centimeter square. In third figure, so we can see there is a triangle and square. So triangle PQR that contain 1 complete square and 3 more than half square and 3 less than half square. So according to rule 4, ignoring area covered by 3 less than half square. So area will be 1 plus 3, 4 centimeter. In figure 23C, the region A, B, C, D, F, E. A, B, C, D, F, E. Clear? A, B, C, D, E, F. Contain 3 complete square, 3 more than half square and 4 less than half square. According to rule, the area will be 3 plus 3, 6 centimeter. Now, we will take example 2. By splitting the following figure into rectangles, find the area, and all the measurements are given here. So, in this question, we have to split the following figure into rectangles and find their areas. All measures are given in meter. So, solution, splitting the given figure 1, 2, 3 and 4 rectangles. So, we have divided the given figure into 4 rectangles and will find their area separately and add them. So, first we will find the rectangle 1, the area of rectangle 1, this one, length into breadth. So, that is equals to 4 into 3, 12 square centimeter. For rectangle 2, 3 into 2, 3 into 2, that is equals to 6 square centimeter. Now, for rectangle 3, the length is 4 and breadth is 1. So, that is area 4 square centimeter. For rectangle 5, so for rectangle 4, length into breadth 3 into 2, that is equals to 6 centimeter. Now, we will add them together, total area that would be 28 square centimeter. Clear? Similarly, in this figure, we have divided into 3 rectangles. For rectangle 1, the area would be 3 into 1. For rectangle 2, the area would be 3 into 1. Clear? So, for rectangle 3, 2 plus 1, 3 and 1. So, total area that is equals to 3 plus 3 plus 3, 9 square centimeter. Clear? Now, next example, find the area of the rectangle whose length and breadth are given respectively here 24 centimeter and 5 centimeter. We know the area of rectangle L into B. So, 24 into 5, 120 square centimeter. Clear? Next example, calculate the area of the rectangle whose length is 5 centimeter, breadth is 24 centimeter. Give your answer in centimeter square. So, here we know the area that is equals to L into B. Here the length is 5 meters. So, we will convert into centimeter because we have to give our answer in centimeter. 1 meter equals to 100 centimeters. So, 5 into 100, 500 centimeter, and breadth is already in centimeter. So, 24 into 500, that is equals to 12,000 centimeter square. Clear? Next example, calculate the area of the rectangle whose length is 12 meter, breadth is 150 centimeter. Give your answer in meter square. So, we have to convert into same unit. So, length is 12 meter, we have to give our answer in meter, and breadth is 150 centimeters. So, we will convert into meter, divide by 100, 1.5 meter. So, area equals to 12 into 1.5 meter, that is 18 meter square. Clear? Next example, example 6. Find the length of the rectangular field whose breadth is 30 meter and area is 4050 meter square. So, area and breadth is given, we have to find the length. So, length equals to area upon breadth, that is 1050 upon 30, 135 meter. Clear? Next example, the area of rectangular children park is 396 meter square. It is 18 meter wide. If the cost of fencing the park wire is rupees 75 per meter, find the total cost. So, first what is given here? Area is given and breadth is given. We have to find the length. Length equals to area upon breadth. So, that is 22 meter. Now, we have to find the cost of fencing. For that we need perimeter. Perimeter equals 2L plus B. So, 2 into 22 plus 18, 80 meter. Now, the cost of fencing per meter is 75 rupees. So, we multiply by 75, that is rupees 6,000. Next example, area of the tile is 48 centimeter square. How many tiles are required to cover the floor of area 5760? So area of tile is given and area of floor is given. So number of tile required, area of floor divided by area of tile. So 120 tiles are required. Next, find the area of square of length each side is 4.2 centimeter. So area of square, side square 4.2 into 4.2, that is equals to 17.64 centimeter square. Next example, the square and the rectangle have the same area. So here the square and rectangle both have the same area, 81 centimeter square. Find the length of each side of square if the breadth of the rectangle is 1/3 of the side of the square. Find the perimeter of rectangle also. So area is given 81 centimeter. Now we can find out the side. Side square equals to 81 centimeter. So side equals to root 81, that is 9 centimeter. Now we have to find the breadth of the rectangle. Breadth of the rectangle is 1/3 of the side of square. We know side is 9 centimeters, so 1/3 into 9, that is 3 centimeter. Now length of the rectangle, area divided by breadth, area is 81 divided by 3, that is 27 centimeter. Now we have to find the perimeter. Perimeter equals to 2L plus B. Length is 27 and breadth is 3 centimeter. So perimeter 60 centimeter. Clear? Next, one more example, example 9. What will happen to the area of square if its size is double? So if we double the side of the square, what change will be in area? So area x square centimeter when the side is double. So side of the new square 2 centimeter. So area 2 centimeter square means 2 square, that is equals to 4. Clearly the side is double, then the area becomes 4 times. So 4 centimeter square. So if we double the side, the area becomes 4 times. Clear? Next is learning point 6.2. Practice all the questions given in the exercise. You have to practice all these questions. Next is area of a triangle. A surface enclosed by the closed shape is known as area. When comparing the area of two shapes, it can be hard to tell just by looking it to get an accurate measurement, to get the accurate squared or the graph paper. When each square measured 1 centimeter into 1 centimeter, is how to measure the area using this method. For that, outline the figure, draw the figure outline on the graph paper. Now we'll count the full and the partial square. Like we have done earlier, look at the square within the outline. Some square will be completely enclosed, other only partially. Clear? To handle partial square, use this simple rule. A fully enclosed square is counted as 1 square unit. If using centimeter square paper, that would be 1 square centimeter. A square that is less than half full can be ignored. Which is less than half can be ignored. If more than half square inside the shape, will count it as 1 square. If that is exactly half covered, that will count at half of the square unit. So area of the figure in the total number of square unit that fit inside it. This technique provides the straightforward way to estimate the area of irregular shape by counting the number of square on the graph paper. So this technique will generally use for the irregular figure. Next, we will take some example. Find the area of the following figure by counting square. So we have to find the area of this figure. Clear? So first we will count the number of square that are fully filled, that is 10, and half filled, that is 5. So 10 plus 1/2 into 5. So 10 plus 2.5, that is 12.5 square unit. Now example 2, find the area of the figure below by dividing them into rectangles and triangles. So the same way we will count the fully filled square, that is 10 here, half tall tilted square, more than half tilted square, that is 4, less than half, that is 4. So and so estimated area will be 0. Here 4. So total area 20 plus 4, because less than half will consider or we ignore it. So 24. Here the area will be 25 plus 4, 29 square unit. In the figure C, the fully filled square, that is 36, whole tilted square, that is 2, half tilted, that is 2. So 1 by 2 will take it, more than half is 8. So area 36 into 36 plus 8 plus 1, so 45 square unit, that will be the area. Clear? Now in the figure D, fully filled square, that is 13, half filled square, that is 0, more than half, that is 4, less than half filled, that is 2. So area will be 13 plus more than half, 4, so more than half, that is 3, and less than half, that is 2. So we will ignore it. So area 13 plus 3, 16 square unit. Next is learning point 6.3. So practice all the question given in the exercise. Next is summary. The perimeter of the polygon is the total length of all sides. For the rectangle, the perimeter is calculated as the twice of the sum of length and breadth. For the square, the perimeter is 4 times of length of one side. The area of closed shape is the shape within its boundary. Area typically measured in square unit. The area of rectangle is found by multiplying its length by its width. For the square, the area of the length of the side multiplied by itself. Two closed shape may have the same areas but different perimeter, or the same perimeter but the different areas. Area of the region can be estimated or precisely determined by the dividing them into unit square or into the simple shape like rectangle or triangle, or for which area can be calculated. So here we end the chapter. I hope you understand the chapter well. Now you have to practice this chapter.